Hello, everybody. Welcome to today's SDQA. Our topic today is going to be what's in a label, and we're going to label some reactions with things like nucleophiles, electrophiles, Bronsted acids, Lewis bases, nucleophiles, and Bronsted bases. Let's take it over to the other screen and get going with the proceedings. Here we are, Lewis acid. And why do we need these labels anyway? Well, it helps us to talk about reactions. To understand reactions, we have to understand how electrons flow. We're talking valence electrons. That's what chemistry is the study of. So we like to talk about electrons in a Lewis sense. And if we're talking about a Lewis acid, the short form can be LA. And I have a quick way for you to remember, and you should always start with Lewis acid in your mind, because here's how you do it. It's the first one that we want to remember. And a Lewis acid is an electron acceptor. So, you know, memory tricks are very important for remembering things. And if you're like me, sounds really work. I have a oral spelled A-U-R-A-L memory, and sounds help me. So I just pretend I've got a little street cred going on, and instead of saying the word electron, I just say electron. Electron starts with an L. Acceptor, I know electron starts with an E, but if you say it like street cred, electron acceptor, then you remember La is an electron acceptor, and clearly it's a Lewis acid. So this is a species that will have typically what type of charge? If you're interested in electrons, you have only one type of charge. You have a positive nature. Electrophiles love electrons. They love accepting electrons. Oh, electrophile is synonymous every day of the week with Lewis acid. Electrophile breaks down its name to philia, love of, electron, electron lover. And what we have here is these two are always synonymous. I prefer electrophile because it doesn't have somebody's name in it. Lewis says nothing to me, except I've been teaching so long. As soon as I hear Lewis, I'm just thinking valence electrons in my brain. That's what Lewis theories are always about. Bronsted is a little more of a specific acid. That's an acid that is going to give a proton to another species. What is a proton? A proton, you have to know this for the rest of your careers. When a chemist says proton, they're talking about a hydrogen ion. Remember the hydrogen atom, the one that's not an ion, the hydrogen atom on the periodic table has a proton and a electron. When you remove the electron, all you're left with is the proton. So that's why it's called a proton. And it's a proton donor. It's going to give its proton to something else. So this has nothing to do with electrons. When you talk Bronsted, you're only talking about protons. Okay, let's flip the script. Lewis base, short form LB. I don't have a memory trick for you. You don't need a memory trick for you. As long as you're always starting with Lewis acid, you'll get the Lewis things straight. Electron acceptor. Well, what's the opposite of an electron acceptor? Electron donor. So if you're going to donate your electrons to something, what is that thing you're interested in? Well, clearly, if you're donating electrons, you've got a little bit of extra electrons on your mind. What's the only thing that's interested in, electrons? Well, things that have a positive charge. So electron donors tend to have a slightly negative charge or a fully negative charge. And synonymous with electron donor is nucleophile. What part of an atom is the nucleus? Well, it's the central part, and it has the protons in it. If you love protons, that means you have extra electrons. So this is a nucleus lover. Remember, nucleus is plus. And these are always synonymous. Okay. And let's talk about Bronsted bases. Oh, we didn't come up with short forms for electrophile. My apologies. I don't know, is he gonna let me move that? Oh, that was nice. And short form is E. And Bronsted acid short form is, let's see how this does. I'll move a bit at a time, huh? Oh, I got the blue. He doesn't want to give it to me. It's being mean. There we go. And a Bronsted acid with a BA. And Bronsted base, BB. And that is a proton, not a proton, a proton. Just remember, proton is H+. I'm going to stop saying proton is H+ very soon. I'm going to assume you know that. Okay. Now, every reaction we study where we use curved arrows, we're going to be doing some of them right now. Every reaction we study with curved arrows, that's mechanisms. We're going to talk about Lewis every time. And your arrows always start at nucleophiles because arrows represent the flow of electrons. A nucleophile has electrons and it's interested in a nucleus. It's going to donate its electrons towards the nucleus of another atom. So remember, arrows always flow from nucleophiles to electrophiles, never the opposite. Okay, so we have all these lovely definitions. We're going to put them in our brain, and we'll do two simple reactions to conclude our video, and we will label all parts, all fitting parts. So we'll start with this simple alkene called propene, and we'll react it with HBr. And we will create 2-bromopropane as our product. You'll have a new Br here and a new H here. There's lots of videos for this mechanism, so I'm just going to do it quickly. Here is the electron flow. And just for clarity, I'm not going to use red for that arrow. Whoa. Ah, good thing there's a control Y feature. I wanted to control X on that. Let's put a good old blue arrow there. Green. Green for go. There we go. So our mechanism starts like this. This thing's clearly donating this pair of electrons to this species here. Electron donor. Okay, well, I know electron acceptor is a Lewis acid. That's this one. So donor must be the Lewis base. What's synonymous with Lewis base? Well, what do you love if you're donating your electrons? Well, you like something positive, don't you? Where's the positive live in an atom? In the nucleus. So anytime you write down LB, you also write down nu. And then you only put a Bronsted label if the thing being attacked by a pair of electrons is a proton. That is clearly a proton. So this thing's giving up a proton. That's a Lewis acid. This thing's accepting the proton. That's a, sorry, did I say Lewis? When you talk about protons, it's Bronsted. This thing's donating a proton towards this thing. It's a Bronsted acid. This thing's accepting the proton. It's a Bronsted base. Yeah, let's put it in a different color. And clearly this thing's a Bronsted acid, as well as its electron acceptor. Look, it's got an arrow pointing towards it. It's accepting electrons from the other molecule. It's a Lewis acid. Lewis acids and electrophiles. Well, it loves those electrons or else it wouldn't accept them, right? Loves these electrons or it wouldn't accept them. Loves electrons, electrophile. So that's the labels for the two species. You either get 3 labels like this reaction, or in our next reaction, which will be the second step of this mechanism, I don't know, let's go gray. Never get to use gray. We made a carbocation, and the H went to the other carbon. There's lots of videos on that. Don't want to keep remaking the same videos. You guys have a lot of videos to watch already. I appreciate that. So I'm not going to try to redo old videos. Now I showed that lone pair on the bromide because it's the new lone pair, and more importantly, I need it to make this bond. The next step in this mechanism, this thing will donate its electrons to this thing. This thing, always start with the electron acceptor. What do you call an electron acceptor? Electron acceptor. Lewis acid. What's electron acceptor always synonymous with? Well, it loves those electrons. That's why it's accepting them. It's an electrophile. Why am I not adding Bronsted acid to the list this time? Is the nucleophile, which is down here, attacking a proton? No, it's attacking a carbon. It's trying to get to the nucleus of a carbon. There's no proton moving from one species to another here. This is donating electrons. Lewis base. If this thing's accepting electrons, this thing's donating electrons. Lewis base. It's also loving the positive charge right up here. Loving positive, so nucleophile. And we got that. We got this. Don't need that arrow to look like that. We're almost done. And we want a pen. It's gray. There we go. Some reactions have all 3 labels. Some reactions have 2 labels. If a proton's not moving from one place to another, please don't use any of the Bronsted labels. When a proton is moving from this species to this species, the one that's giving up the proton is the Bronsted acid. The one that's accepting the proton is the Bronsted base. And I hope this segment proves useful to you when you label things on your next test. And I'm going to come back after a short break and see if anybody's there to do other SDQAs for today. If not, then happy studies. And we'll see you.